I too would wish for the same.
Wait, hold on. I felt like I just legit just missed.
Solo. Hello. Don't know who's here, but I know somebody is, or I suspect somebody is, which is good. And the mic, the sound levels look good this week. What else is going on? What else is going on that's exciting this week? Sound levels are good. I will remember to switch to the non-individual view when when it's time to go into the desktop view stuff. So there's that. What else is exciting and fun this week? We're seeing who's arrived. I can tell you that this week is actually pretty dense in places. I was a little worried. Hello. Oh, thanks for watching on YouTube. That's way better for the algorithm. Long term, I want to move everything to YouTube long term, but I'm streaming everywhere now, so people have a choice as to where to find me. So it's sort of like, but YouTube is best for me. For you, you can watch wherever you're comfortable. I don't mind. So yeah, as I was saying, this week gets like really dense in places, and I've done my best to boil it down. I was a little worried earlier on before I actually had read the chapters, and oh, nice, that's good. I think one of the things that I'm going to do if I get most people watching on YouTube is I'm just going to stop streaming everywhere else, which will allow me to upgrade the stream quality. Currently it's 720p, but I could go as much as I could do 1080p or sort of full proper HD, which would be nice. So that would be good. Yeah, so I was saying the reading is a lot more dense this week. And I was worried at first that solid principles, there's 5 principles, maybe you should do it in one big block, but it makes a lot of sense based on what I've read to go much more slowly through it. So I see 2 people are here. Is one of them, is Rajat here as well? Anyways, doesn't matter. It's okay. Doesn't matter who's here. Everybody can watch it back later. And that's actually what I started. Oh, this week I am also going to remember to change back to sharing my notes. So here we go. These are the notes from the chapter. So one of the warnings right off the bat that comes out of what we're about to talk about is that the solid principles in the book don't actually spend a lot of time talking about what they are specifically. So a lot of what you have to do when you're reading through this is either infer what he means by single responsibility, open-close principle, Liskov's substitution principle, interface something or other, which we'll check again later, and D. D is dependency inversion principle. So we don't really get into what they are, but I thought that it would be nice to have a refresher, and the children's book version of S.O.L.I.D principles I thought was pretty good. I'll also talk about those in a bit. So this is Ugana Thelma, and she is a children's book author and programmer who has gone through and tried to explain S.O.L.I.D. And so rather than dwelling on the article, which you can read on your own at any time because it's linked up, I thought we would skip through to the pictures themselves. So a class should have a single responsibility, and the picture here kind of describes it quite well. You could either write one class that has chef, gardener, painter, driver, or split each of those individual responsibilities out into a single standalone class. One of the really interesting ways, and we'll see this later in the notes, is the author says that if a class is each class should be responsible for only one actor in the business context. And we talk about this later. So if you have a record where the finance department is interested in something, and a record where the so finance, and then you've got HR is separate from finance, you should have two files each for the changes. We'll talk about it. It's an interesting point. It does result in more files, but in theory also results in fewer conflicts in terms of code check-ins, right? So there's one thing. But the other one is a function. Functions should not be shared between business units or customers or entities, because one of them might require changes to happen in one way that the other one won't even know about. And so you can accidentally introduce bugs if you don't deeply separate your concerns like that. The open-closed principle says changing the current behavior of a class, changing the current will affect all the systems using that class. That's not really what I got from that. So, but anyways, that's what this one is. So in this picture, I think the better description of open-closed principle is that a class should be able to be modified without altering the old code, but instead by adding new code. So that's sort of, if there is a way to work with hooks or plugins or anything like that, that's superior, because you don't actually have to change a working system. You just add additional code to the system that you already have, and you separate things out here. So here, Liskov substitution. So I mean, it's the substitution principle, and they had to name it after Barbara Liskov, because if they didn't name it after Barbara Liskov, then it wouldn't be the L in it wouldn't spell solid. The other nice part is she's it's nice to acknowledge the people who invented things. So she lucked into that one, and she deserves her recognition. So if S is a subtype of T, then objects of type T in a program may be replaced with objects of type S without altering any of the desirable properties of that program. So let's see if this one, hi, I'm Sam. I'm the child of Sam. So the child of one. So this one, the tiny one, should be able to make coffee because the parent object can make coffee, I guess. And so in theory, what this is trying to say is you should be able to replace objects with objects of an inherited or a similar type. It's about substituting one object for another. In a development context, this makes a lot of sense within a testing framework where you might build a fake object to test against versus using a real object, using a real version of the object. So interface segregation is the interface segregation principle is to say that since we know that all interfaces are contracts or they are agreements outside of the detail level, the code level details of our work, interfaces, and you can implement multiple interfaces. You should only you should only implement interfaces should only implement the methods they depend on. So you can see, so this is all robots. So if you're going to make an iRobot, you say iRobot has to have wiggle antennas, rotate their arms, spin around. Well, doesn't it make more sense to have 3 different interfaces? Because some robots, as seen in the picture, don't actually have antennas, right? So it's if you keep your interfaces tight or lean, then you will be in a better position long term. And I don't know if you've been here before where you're trying to implement a class that based on an interface, and there are so many things in the interface where you just say not yet, you throw not yet implemented exceptions, and sort of this is about eliminating all of the extra boilerplate code you have to fill in around those interfaces. Now, finally, the D in this, the dependency inversion is you instead of accessing objects directly, and we've talked about dependency inversion in a previous week as well. So instead of accessing objects directly or accessing methods directly, what you do is you pass in the function or the object containing the function that you're going to use, and by doing that, you can swap the thing that you're passing in. It's very much like, I mean, honestly, it's very much like substitution. It's part of that. It's part of that substitution framework. So, and again, this is all just a review of what these solid principles mean, and they don't cover this at all in the book, and it's not relevant within the scope of the book, because we want to talk instead about how the solid principles affect our decisions with respect to architecture. So we don't spend a lot of time on that. Now, there are some other things. You can look at the Wikipedia if you want to learn about them. There is a quite long, we're not going to watch all of this, but there's or in fact, any of it, because there's so much content on Solid that's already out there right now. It's really not in the scope of what we're focusing on right now. But so you can get a hour-and-a-half video here. My personal favorite choice for this one is I've spent a lot of time watching this guy, Jason Wyman, who, and we're not going to watch the whole thing, but the really exciting thing or the fun thing about Jason Wyman is that he is a Unity or a video game programming streamer who goes into deep detail on the solid principles. He has a video for each of the individual topics. And what I really like about this is...
Hey, what's up? Jason here from Unity3D.College. Today we're going to talk about...
You see, and again, we're not going to watch this whole thing, or any of it, but the nice thing about trying to understand the solid principle... Oh, I should click like... trying to understand the solid principles in the context of what Jason is doing here is because he works with video games and we're working with physical behaviors, it all becomes very concrete because you can see what's happening in this situation. He'll have my spaceship shoots bullets, but and so, or my spaceship shoots bullets, and so I need to make it a bullet shooter. And so he breaks off a class for a bullet shooter. And then he says, but my spaceship also has a health property. And so he says, so I'll break off a single responsibility for has health properties. And then what is really exciting is when he goes through all of this stuff, he on some of these things, he says, oh, well, see, we can reuse this health property on my enemies as well. And so it really brings together. This is the number one thing I recommend for learning S.O.L.I.D is watching the video game based stuff, because you really see how it comes together and it's a little bit fun because it's video games and things. So that's really cool. So these are all just recommended reading to get yourself up to speed on what is being talked about in the S.O.L.I.D sense. It's also possible, if you are reading through the book, for the most part, if you're reading through the book, for the most part, it's possible to just infer what he's talking about. You don't necessarily need a very, very deep dive into these principles. So moving on, there are 2 chapters, Chapter 7, Chapter 8, and then this is the beginning of the broad section on S.O.L.I.D. So we talk about the architectural goal of S.O.L.I.D principles is to create what he refers to as mid-level software structures that they tolerate change, they're easy to understand, and they are the basis for components, which we talk about in the next section. So it's probably not even critical that we fully understand what we mean by components at this time, because we do go into detail about what that is later on. Now, mid-level code is described or defined as sitting at the module level. Now, what does a module level mean? It's a little bit more than a function. It is less than a complete standalone system, mostly, but it would be what would be a good description of a module? I should have thought of a better. There are examples later on, but a good example for a module in this context might be the data layer, the database communication layer as part of your full web app. And so you would have a data module that sits off in its own project, likely, or something like that. So the data is a module, and then the presentation layer is a module, and then the calculate something or other is a layer. Calculate drug tolerances, right? Because we spent so long working in healthcare. So calculate dosages for your drug. So each of those would be standalone modules. They are, and I'm still not sure, based on that, how that differs from components. And I'm hoping that later on in his reading, he gets into detail as to how modules differ from components and what specifically components are. I assume components are just slightly bigger modules, but we'll see. We'll see what they are. Now, so again, we just did the pictures. I hope those were okay and not too bad. Single responsibility principle says that each software module has only one reason to change. That's at the code level. That's even separating between different departments who might rely on these things. Now, the open-closed principle, which we've said once before already, code should be able to be changed by adding new code as opposed to editing the module itself. And to some extent, we can have that today. We're going to learn that. So, Liskov substitution principle. All parts must adhere to a contract that allows those parts to be substituted for one another, which is to say that if you are using, here's an example of what you might do with that. You might have a MySQL database and it has a handful of functions that you call to save your data and to read your data, but you might one day talk to someone and say, actually, I'd like to use Postgres, or actually, we'd like to use SQL Server, or it might be the other way around. You've already got yourself a Microsoft SQL Server that costs $26,000 a year for a license, and somebody comes along and says, can we switch that to Postgres so we can save $25,000 a year? So what you might do in terms of substitution is you would substitute one database for another database. The way that you can make that happen in a seamless way is if you have a wrapper layer or an interface layer between the actual database that you're calling and the database that and the rest of your application. So in that case, you would just have to, as long as you could reuse all of the functions in that interface or the contract, you could swap out whatever your backend database was seamlessly. Interface segregation, I thought, was pretty useful in that other set of diagrams. Interfaces should be as minimal as possible, and only the things that are required for that interface should be in that interface. Don't make it do a dozen things. Make it do only things related to what its core functionality is. And if you need to implement multiple interfaces, go for it. That's cool. And dependency inversion principle, again, as is very similar to Liskov's substitution, and it is about how the details. It shouldn't matter which database you're using, or even if you're using a database at all, so much as it matters that you are able to swap those things out. And so I think we get a pretty good example of this today, even in the open-close principle. So here we go. What else did I say here? Chapters in CL, that's supposed to be CA. The chapters in clean architecture focus on the architectural implications of S.O.L.I.D and not specifically what S.O.L.I.D is. And the further note is that I've also already said these are dense, and it's a good choice to go slow. So that's part 1. And how did I do? 25 minutes roughly. So these next 2 parts, so we're probably going until 9:30. This gets pretty dense. So here we go. Single responsibility principles. So any given source code file should be responsible for one and only one actor. And again, by actor, they mean business unit. So There are some major implications of the two major implications of doing this wrong. Accidental duplication. I really don't like the headline that he put in for that, but what he's saying effectively is, if you know what, I'm going to skip that because it gets really clear in the example of how it can be done wrong. And merge issues, two people working on the same file for different reasons. Maybe you can't launch. Who's that? Oh, Glenn. Hi, Glenn. Good to see you. Thanks for coming by. Pebs is over on YouTube today, just so you know. So we're watching in multiple places. So the merge issues are twofold. So first of all, it's if you are both trying to make edits on the same lines of code, that's a problem. But the other one is if you have two departments, so you have a finance department and the human resources department, both of them are trying to get changes done on the same system, the same file. If they are in the same physical file and one wants to launch their changes and the other changes are halfway done and not ready to go or broken, then both departments are unhappy. So here's an example that is the bad example. The goal is to not design things and do it this way, is if you have, for example, an employee class in your payroll program and it has multiple functions within it. One of them is to calculate their salary. One of them is to report the hours that they have worked for the week. And another one is to save the changes to the record. So that would be their name changes, or they have a new address, or just whatever, or their title changes. That's one section. And calculate pay might have a whole bunch of different rules, like all of their work. Some salaries might be commissioned, some employees might be commissioned while others might be salaried, and others might work hourly, and some of the hourly workers might be in a union, and if they're in a union, they are going to get time and a half every hour they work after 40 in a week or whatever, right? So things get really complicated in the calculate pay field. But if we're looking at these in a situation where, for example, line managers want to look at the number of hours somebody has worked in the week in terms of the real hours that they have been in the building, versus finance, who says we actually want to count every hour after overtime as 1.5 hours. Now, you could have two programmers from two separate teams updating this system at the same time. And so the finance department calls down to their group of programmers and says, if the user has been in for longer than 40 hours, count every hour as 1.5 hours, and so on and so forth. And so they check in the thing, the program launches, and managers are suddenly saying, well, why are all of these people here so much longer than all of these other people, right? And so there are ways for bugs to sneak into a system if you are accidentally duplicating the usage of a single function that has multiple stakeholders, right? So there are multiple real live people who are invested in the content of your code. So these are the things that we're talking about. I hope that's clear, because this one took me not as much time as the open-closed principle, but this one took me a little bit of time to come around on. to understand the example. So, and these can be really costly. So the solution to this problem, you've got your employee record, and you want to break it out across multiple. You want to break it out across multiple files. So, by moving each of the functions, and these are not just individual functions. You would want to move everything that is used by the finance department into the finance department file, okay? And then you would want to move everything used by human resources into the human resources file, and you would want to move all of the manager stuff into the manager file. So when human resources calls you up and says make a change, you make and launch the change, and everybody's happy. And then and then finance wants a change, and managers want to change. All of these things can go live without risking the content of the other teams. So here's a drawback of like load distribution of your function. Yeah, well, yeah, I guess so. Exactly like that. That's pretty good. But here's one of the things that came up while I was reading this. Well, we've got this thing called the don't repeat yourself as a principle, right? So they say, don't, like, if you have to write a function twice, why not just call it once and everything's fine? So there's a question. How do we rank these principles when they conflict with other principles? And I think partly the context of clean architecture is about giving clean architecture, the book, is about giving us a way to rank these rules, these principles, or at least understand the trade-offs when we are doing this sort of work. So I actually have a story of one time where I made this mistake pretty badly, and now the website is out in the market, and it was a client page. Oh, should I show it? I'm going to do it. Okay. So, here we go. This is a website that I've seen code bases where each method was put into its own class. It was very complicated to understand what was going on. Right. And so there's a thing where one issue can kind of conflict with another. I think the multiple actors issue is a good way of organizing it. So I'm not sure. So you could cluster groups of functions. I also think it's rare at least in the programs that we generally work on, I think it's really rare for us to have more than one owner, if that makes sense. At least in our applications as agency developers, but it's important to think about programs in these terms for working in places that aren't agency, right? And also for the idea. Anyways, yeah, I mean, there's another section where he goes into detail about dealing with use cases, and we can talk about that. Will come up later, is the thing about use cases. Anyways, back to this story. We've got two major sections to this website, and each section of this website is owned by a different brand or a different client. So if you look here, you've got your urology indication, and then you've got your advanced prostate cancer indication on this website. I'm not 100% comfortable leaving this up. I'm going to close this. But you see, both of those are live at the same time, and two customers hosted on the same central website, and one customer can call us up and say, we've got this project that's launching, and then another one say, well, we've got this project going at the same time. And what we had to do as a business unit was stagger their launch dates and not get them mixed up. Whereas and the reason that happened was I prioritized don't repeat yourself, and so one section inherits from the other section, and there's very little. It's like the second page is barely any extra code. It's like a handful of replace, and so is you replace a handful of names, and that's it, and it's perfect. And so that's a really elegant feeling solution, except when you try and live with it in a launch scenario where both of them want changes to their website, but you can't make them or launch them unless you do it in a certain order, and you have to negotiate that. So it's again, it comes back to this question of how do we prioritize the principles, and how can we be aware of the trade-offs? And I think if we're going to make a choice, I think leaning towards going with what Uncle Bob suggests would, at the very least, allow us to make use of his, I think, what does he say, 40 years of programming? Like, he has as much programming experience as I have experience being alive on this earth, or maybe a little bit more. So it's just it's at least a consideration point that sometime, anyways. So that's the first one. He says, move the functions into different files. Now, when working with something that's as complex as all of my code is scattered across different files, like the situation Pebs is talking about right now, it's a pain. And so the solution to the solution, he says in the book that these are two different solutions, but realistically, the first solution is the way to fix one problem, but it introduces another problem. And so the solution to the problem that he introduced is to use something known as a facade pattern. Now, I'm again not really. We're not going to dig into or watch these things. These are good for you to go back and look at if you want to dive into them. If I look at, let me see, I liked this one. This one has high production value. This one we should recognize the guy behind them. I think this one's probably the best.
All right. What we're going to talk about now is...
You probably remember him from the other day, but the facade pattern is if you have a number of different files each related to your employee object, and each of those files has to be called, you might make something called a facade, which does all of the work of loading those other files. So you've got your 5 or 6 other files over here, and you've got your one facade. And this one, you say, when you want to work with an employee, you say, give me one new employee facade, and the employee facade lifts all of this stuff into it, slots it into place, and then you can work with it like it was a single object, right? So the programmers that are consuming your massively broken down object, they don't suffer because they just use it like it's a single normal working, oops, sorry, I didn't want to bang your microphone listening. They use it like it's a single working object. And so that's the piece that brings that together. And even like you're saying, Pebs, where each method is in its own class, which I also agree sounds a little terrible. But if there was a facade in that place, at least for using the object, you would still just load one object, and that one would do all the heavy lifting. So so the single responsibility principle is about functions and classes, but it is critical and returns to us twice more in different forms. And what that means is SRP deals with this sort of low-level individual program optimization system, but later on, when we get to the system called components, there's an SRP analog called the common closure principle. And so we're going to want to watch out for that and see how the parallel, you know how in a previous week, Uncle Bob said that working with code is fractally complex. This is like an inverse fractal pattern, because as we zoom further out, we can still see that pattern, that single responsibility adds value in theory. And then the next thing that we'll learn about is, on top of the component principle, we have the architectural boundaries principle, which again is a fractal zoom out onto, so we see the echoes of the single responsibility principle happening throughout the architecture. Or at least that's what I think, because we are not there yet, and this is merely foreshadowing what we expect will come. So that is the end of the single responsibility principle. We are at 8:43, and so if we manage to get through in the same time, we're likely done by about 9:15 for tonight. And hello to the new people who have arrived. Thank you so much for stopping by. And let's talk about the open-closed principle. Now, this one, for me, was the hardest one to wrap my head around. I made this amazing diagram. I hope you love it with all of your heart, because I spent hours trying to get it to work. And what did I say? I posted to some of my friends that this stuff is not actually UML, it's FML, because fuck my life. Why won't these damned arrows work properly? I had them all pretty and everything was laid out. Then I hit one thing and they went stupid wonky. And I said to myself, it's late. The name of the podcast is Ship It. So I'm just going to ship it, even though I could have spent hours cleaning that up. So that's fine. It's fine. It's fine. You don't have to be embarrassed. It's good enough. So the principle itself is that a software artifact should be open for extension and closed for modification, meaning I think this diagram, and we want to organize our dependencies in a one-way fashion, and this is, let me zoom out. Can I zoom out a notch or two? So I zoom out a notch, and Right. Hi, Hussein Webb. Thanks for coming back. So if we look at this system, what's actually, even though the arrows are a little wonky, the database is intended to only rely on, so all of your business logic lies within the financial report interactor. So this is where all of your calculations happen. Whereas in the controller is about gathering that report and displaying it to a user. And then you further separate this into presentation types. So you could have screen presentation, print presentation. If we wanted to, and if you look at this flow, the arrows are all supposed to point only in one direction. You'll see that nothing here only goes one way, and here only goes one way. And these are, so what is this? The white arrow is an implementation. So these guys are actually implementing an interface that is published by, so the print presentation layer publishes an interface that is consumed by the display layer. And so, but you'll see that the inheritance relationship or the implementation relationship, this one is, again, everything's only supposed to go one way, goes one way, one way. And so what we're seeing here, and it's written right here, if a system or a module should be protected from changes, then we make sure that the other modules depend on the thing that should be protected from changes. So we effectively set this stuff up in a hierarchy from top to bottom. And so our interactor, which this is where the calculations happen. This one, everything else depends out from that, right? So if we have any changes that need to happen to the database, they can happen without risking the business rules. The business rules are key. Everything, the business, the most important thing. So if the gathering of reports, right, the financial report controller, the thing that outputs it to the screen, wants to change, we don't have to change the business rules, right? And so the interesting thing about this one right here is maybe we want to design, for example, a mobile presentation layer, right? So we've got screen, so assume that's a desktop presentation layer, a print presentation layer, and we want to add a new feature, call it the mobile display layer. How would we implement that? Well, we would copy and paste the screen presentation layer, and we would just rename a few variables to mobile, and then we would do the fine tuning when we got down to the actual presentation views and things. But what you get from that, in terms of this idea of the open-closed principle, we are adding new behavior by adding new code. But did we have to edit screen presentation? No. Did we have to edit print presentation? No. Did we have to edit the financial report controller? Probably not. Like, effectively, no. And we absolutely didn't have to touch the business rules because everything flows out from that, right? So what we're doing in terms of the open-closed principle is we are planning ahead on ensuring our dependencies are not tightly coupled. We don't want them to be interdependent. We want all of our dependencies to flow in one direction, and that's the story here. Now, that one seems pretty simple, and in the book Clean Architecture, these two images are actually reversed. I reproduced them for the show in draw.io. And the next one is actually deliberately complex, and it might make you cry. I didn't really cry, but it's definitely complex. And what you want to remember is the one that I'm about to show is the same situation, just in more detail. And so this is how you achieve these sorts of things, mostly by, I think this one probably should be an interface as well, if I'm honest. I'll check the original source. Anyways, so what you see is, in order for, financial report presenter interface, for example, has, the screen presentation controller, the print presentation controller. If we wanted to invent that mobile presentation controller, we would take something like the financial report presenter interface and implement the contract that is published by the financial report controller, right? And the web view here implements the interface. And it might be a little hard to think about this, but by doing all of this stuff, these extra layers, so you write an extra layer so that the print display controller and the web display controller don't have to be tightly coupled with the object that they're inheriting from, right? So you don't want to be in a situation where you have to change the screen presentation layer, the screen presentation controller, model, or interface to update your web page. You don't want to be in a situation where you have to update your print presentation view model or your controller because you have to update the thing that happens on the page. You definitely don't want to update your business rules. You don't want to update your database. You just want to have things flow in one direction. And so effectively, the open-closed principle is about finding a way to make sure that things are successfully isolated out, and so the things that are more likely to change or they will be on the periphery, and the central systems are more firmly protected. And by setting those boundaries between, each of these would be considered a module in the context of what Uncle Bob is talking about. So this way. So to make this a little more concrete, the screen presentation or the print presentation, each of those might be a different route on your website, for example. So notice, however, how changes to any systems outside of the interactor will have no impact on any other system. That's another really good point. I'm going to scroll up to this one, and you'll see how there's no connections between these systems, right? These systems aren't aware of each other. This system is not aware of this one. It's actually not aware of any of it. So the fact that these systems are more further separated apart means that each one is safer to be changed in isolation. And you'll also find that this is a lot like what we talk about when we talk about microservices architectures as well. A lot of this should start to feel familiar. Notice also that the additional complexity and work around the nightmare image up here are all in place in order to ensure dependencies are pointed in the right direction. So that's to say that this could all be just a single class. But if this was a single class, or this could be a single class, but if these things were not separated apart by these interfaces as buffer layers between the next phase of the project, things would be more tightly coupled. And so this additional work that you do is to ensure that the velocity of your project stays high over time because things are separated properly. So, and this is all about serving the business needs and ensuring the long-term velocity of the project, your ability to continue developing, your ability to understand the processes and understand the complexity. So by ensuring that the systems flow in one direction, you could add, as I said earlier, you could add a mobile view without disrupting any other system. And that's part of what makes this so exciting and interesting. And here we are. So the goal of the open-closed principle is we don't need those up anymore. We'll just go solo because we are finishing up. Look at that, just an hour to get through this stuff. So the goal of the open-closed principle is to make the system easy to extend without incurring a high cost of change. You do that by partitioning the system into modules or components. We'll learn more about components in a coming week. By arranging them in a dependency hierarchy, and by arranging them in a dependency hierarchy, the higher level components are protected from changes in the lower level components. And that's, in this case, all of this is about, well, system design. This is how you set architecture to ensure that you're designing a system that can be maintained by teams over time. That's the story, and that's the week that's everything. And so, who else is here? So Glenn, you've just got a couple of days until you're back at school, right? I kind of miss the bit where we chat a little and we get the updates on what's going on. We know on the 7th, and this is what's the exact course again? I vaguely recall we were talking about combining like lighting with technology, and you were going to do a hardware class, weren't you? Is that what it was? Hardware, electronics, yeah. So that's going to be. Oh, the hat and the towel. Oh, yes. So this is exciting too. My Zensurance came in, and like my Zensurance swag. So here is the T-shirt, and it's got like these sort of like, this is so much for me like a 1980s style camp T-shirt that you'd see in like you would see it in Stranger Things and think it was cool. And then what's this? And we got this gorgeous, look at this, this gorgeous beach towel for going to the beach. What up? Beach time. Woohoo! And it's a super soft, fluffy towel. I don't want to get anybody upset, like if any of the people who design the swag are here, but I'm not quite as big a fan of the hat. But like, maybe I shouldn't say that. Maybe I should just be nice. So, I mean, the hat's okay, but I really like, I'm not going to lie, I really like the one that Malu made for us. She made a really nice, oh my God, I shouldn't even, I feel like such a I feel like such a catty bitch showing this one off, but like it's got like the solid back instead of the clip back, right? So like, oh no finger, oh you can't do that. And then look at this, like the logo is so understated. It's black on black and like embossed threading. I'm sorry, but like does that make me an asshole? I don't know. I like, oh, free hat. Let me turn my nose up at it. But, you know, it's nice. The towel is nice and the t-shirt is amazing. So, but, you know what's fun, though, is we're going through this same book at work as well. And, oh, they were really nice. Malu is, she's a brilliant designer. Yeah, we're doing the same book at work at Zensurance, and the cool thing about what we're getting out of it there is, like, and we're a couple of weeks behind on that one. We're going a little slower, but people are having really in-depth conversations about how the stuff that we're learning in the book applies directly to the code that we're working on in the product. So I think today's discussion at work was around functional programming, right? Because we talked about, structured programming. And we were talking about the fact that actually there are different styles. There's sort of object style, and then there is slightly functional programming in places. And we're talking about where is that appropriate, where is it not appropriate, and what we sort of decided or came to a conclusion of is that it isn't so much as important that we pick a style and stick with it, but that each individual team within the larger, because we have a mono repo, so we have each individual team working on sections should choose a style for their section and then be able to articulate the reasons for the choosing of the style to new team members. And I think that's really exciting that we're having these sorts of conversations as an organization, there were out of, I think 15 of us were there today. Between 15 and 20 were in the discussions today. And the NJorg is about 50 total right now. And so that's, and there is a rotating cast. So we're 2 weeks in and we've had different people show up in different weeks. And so what's really interesting about doing this is everybody from the freshest, newest in career developers to the senior management and the vice president of engineering are all sitting around talking to each other about what their thoughts are on architecture, the architecture that we have, how would we like to see it going forward. And we get this great diversity of opinion because for me, listening to newer developers say, well, I'm really confused by that, is really helpful because it helps us organize the code base to just move beyond complexity entirely, right? We try and really help this stuff. I don't know. It's really helpful to be working on this at an organizational level across the company, like very exciting. So definite recommend technology book clubs, because we did a number of book clubs on like checklist manifesto and getting things done and the power of or atomic habits, and we did all of those book clubs and they were great for the entire organization, but for the health of the engineering organization and for the health of our code base, going through as a whole team is really quite a revelation, I think, because everybody, and I'll call out Glenn as being our example of as a boot camper. It's and or myself as a relatively self-taught engineer who's just been at it for a lot of years. This sort of academic discussion, you're understanding industry-wide best practices. You're getting to have those discussions, and you're kind of seeing that all of us have these areas of uncertainty around the imposter syndrome, right? That we keep talking about, like, oh, I'm not a real programmer. I'm just a fella who lucked into a job one day and then stuck with it. And so I think that it's really encouraging to do this as a group at work and with you. So anyways, that's the week. How do we feel? How do we feel about this one? Was it as hard? Did you find it as hard and complicated as I did, or did it come across okay? How did you feel? I'd love to hear a bit more. What else? I'm going to grab my other notes. I had other notes from today. What were my other notes from today? From today's discussion? I wrote down a few things. What was this? Oh yeah, we talked about one of the things that was cool that we talked about today was, because it was a few weeks back, we talked about how we actually don't do mathematical proofs anymore in terms of deciding that code works and code is really code is, absolutely definitely going to work because we could do a mathematical proof. So yeah, I think that's fair, Pebs, is that, like, the reading from the week was really dense, and there are a number of samples and examples of the stuff that we were talking about, but you really do have to dive in to get a sense of what's going on and what's coming along. So anyways, and so while we don't use mathematical proofs in determining whether our code is going to work for sure, we actually still do mathematical proofs in the scope of determining the scaling, the time and space complexity. And so algorithms for themselves actually still use mathematical proofs. And so I thought that was interesting and cool. But that's everything I have for the week. We'll bring back up the list. So for next week, it's 9, 10, and 11, which is going to be the L-I-N-D. So S.O.L.I.D. 9, 10, and 11. And I have yet to make the notes. So if you want to read ahead, you've got to do it in the book, because I haven't done the notes. So there you go. That's the story. That's the story of the week. Thank you for coming. And here, I'll switch to solo. And we'll wave. No problem, Glenn. Thank you so much for coming. And Pebs, and we will talk to you all. And there are 2 mystery guests. Oh, and Hussein. And Hussein is here. Thank you. And Dexter. Hey, Dexter. That's awesome. It's good to see you. All right, we'll talk to you later. Stopping the stream.